Aloha class, here we go. We kind of got cut off at the end of that 5-2 video. So we have two problems we have to look at. I want to make sure we're all good with that max, min as we graph these, okay? My calculator's good to go now. So here we go. Let's roll. All right, here we go. I want everybody, we're going to go ahead and do 38 on that page, all right? So go ahead and type this bad boy into your calculator, all right? Hit pause if you need to, all right? But it's x to the third minus 7x squared plus 7x plus 15. Like I said, hit pause because I'm going to get right after it, right to it. All right. So here we go. There it is. Hopefully you've had enough time to plug that in. And remember, we're always going to go zoom 6 to get it started. And when I do zoom 6, if you notice, the max is just a little bit higher, but the min ends up being in there. So let's go ahead and just adjust our window a little bit. We just have to get a little bit higher. Once again, I do not like looking at those scales. I'm going to go, I think if I go to 20, that's going to be high enough. So let's see if I hit the jackpot. Spling and spling. All right, so they're both in there. Let's go ahead and find the minimum this time because last time we found the maximum, okay? So we just go second calc. We're going to choose the minimum, which is 3. All right, and then remember, we're going to go over to where the minimum is. I know gosh dang it, my face is in the way, yo. So let's just do that. Okay, we're going to come over here. Okay, there's the minimum. Remember, you go left 2 times, you hit enter. And then you go over to the right 2 times and you hit enter. And then you hit enter again, and the minimum has to be in between those. And this time we get decimals. It's okay. So you would write down the minimum value. The minimum value is negative 5.049, and it happens at x equals 4.097. And you want to make sure you say it that way, okay? And so here I'm gonna put down how one way that we would say this. There we go with that. And then if I do this, I think I can kind of get it organized a little bit. And so the way we would write this, okay, and this is for 38 right here, okay, is we would say it has a minimum value of y equals, what was it, negative 5.049 and occurs at x equals 4.097. Or sometimes you might just say, what are the coordinates of the minimum? And then you would list them out, 4.097, comma, 5.049. All right, but that's it for that bad boy. We just have one word problem to go, and then we call this lesson donezo. All right, I am going to get my video back. There it is, and let's get after it. All right, so here we go. All right, now this is I mean, stores, companies, real estate companies, I mean, all kinds of companies, right? We all make boxes, right? We make boxes out of cardboard. We make boxes out of sheet metal. So what I have here is I have an example of what I'm talking about, okay? And it is boom. How about that? That made a box out of sheet metal. Now, how did they make this box? Well, they start, okay, with just a rectangular piece. You know, the one we're dealing with, I think it said it was 16 by 18. And then they cut out these little corners. And after they cut out the little corners, they just fold them together and you get this beautiful box. So that is what we are doing, class, with this problem today. All right. And if you noticed, we've kind of got this box right here. It's 16 inches by 12 inches. And we're cutting out these X's. And the question is, what do I cut out? How many inches am I going to cut out to get the maximum volume, right? We want the biggest box possible, what I could fit the most clothes in and good stuff like that. So it gives us some hints of how we want to do this problem. It starts with A, which you want to find length, width, and height of the open box. And you always want to relate this to any variable that's presented in the problem. And the variable here is X because we're trying to find out these different, what's the height, what's the length, and all that good stuff. All right, so we're going to go ahead and write length. We're going to define some things. And we're going to let length equal, the length is not 16 because you're going to take away X there and you're going to take away X there. So we're going to say the length is 16 minus 2X. Does that kind of make sense, class? right? If I have x on the left and x on the right, I'm going to subtract both two of those x's. All right, just the same thing with the width now. Okay, what the heck would the width be? Well, the width is 12, but you're going to take out an x there, and you're going to take out an x there. So the width is 12 minus 2x. Okay, and then last but not least, they tell me to find out what is the height. What the heck is the height? Well, if you remember that picture I showed you earlier, the height is just after you fold it up. And the height is going to be whatever x is. Okay, so we're going to have height equals x. Okay, and there we go. There we've defined what length is, we've defined what the width is, and we've defined what the height is. Now, part B says, use your expression from part A. We have to write a function, right? Because we want to know what the volume is. Well, volume of a rectangular object, right, or a box is simply length times width times height, right? You learned that back in 8th grade. All right, and in your geometry classes. So all I have to do now is, okay, volume, and we like to write it in function notation, which would be v of x, just kind of like how we had f of x. But v of x is equal to the length, which would be 16 minus 2x, times the width, which would be 12 minus 2x, times the height, which would be x. And then, believe it or not, you're actually kind of done with the problem. Now we just turn this into a calculadoras problem. So let's go ahead and move this guy and put him fancy. I think if I go like this, it uses up just a little bit of the screen. We're going to get my calculator out. There it is right there. And we're going to go to y equals. Now, my best guess is I'm probably going to have to really change this window. Let's go 16 minus 2x. Okay, parentheses. And then we're going to multiply that by 12 minus 2x. Okay, that's looking good. And then we're going to multiply that by x. Okay, and then I'm going to go zoom 6, right? Because we want the standard viewing window. Now we need to find out what would x be to maximize this. So believe it or not, it's going to be just like those problems, just like the problem I just did. Now, I don't know about you, but this looks like it goes way so far up high. And believe it or not, since this problem is asking us, it says right here for just the max volume right there. You see that, guys? We just care about the maximum here. So let's go ahead and find out what this maximum would be. Now, I need to go to window, and I need to go super high. I really, really do. I'm going to change my scales to 0. I'm going to go all the way to 100 because I got a feeling I got to go way up there. I'm going to go scale to 0. And then I'm just going to hope and pray that it's in my picture. Let's check it out. Come on, graph. Oh, snap. This is a big box. It's going to hold a lot of water, a lot of stuff in it. I got to go higher. Man, you know what? I am going to go to 300. I am going to go to 300 because I do not want to keep on doing this over and over again. Come on. It's got to be in there, doesn't it, class? And then what you're going to find out is this there, sweetie sweets. The max is right there. So what do I do now, right? I go second, calc. I choose max, which is 4. I go up to the max. Boom, 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 boom. And then I go, it's about there. So I go left 2 times. I go back to where the max is, and I go to the right 2 times. And right, your max should be in between those two. That's what that means. And we get an answer of, it's 2.263. All right, so so we have to really make sure we relate this to our problem. All right, so I'm going to go over here. So x equals 2.263. That is what x is. And guess what the y is? The y is actually that, remember? Because sometimes instead of function notation, we write y equals. So guess what? The max volume of this box is 194.067 cubic. God bless me! Cubic inches, okay? Excuse me, class. I was sneezing it up. All right, now we just have to tie it all together. We're really donezo with this problem. That is actually your height. So I don't know if they asked you to find the max volume. We did it. It was right there, 194. And they don't. But they sometimes ask you, well, what's the height, what's the width, and what's the length? And so you just have to come back here and say, okay, that is the height. The width would be 12 minus 2 times 2.263, whatever that answer is. And the length would be 16 minus 2 times 2.263. 263. And to get those answers right, you would just use your calculator. So why don't we just finish this guy completely? Okay, so it'd be 12 minus 2 times 2.263, and that would be the width. And then we would go 16. And so make sure you guys write that in your answers. I thought my calculator gave out on me again. 16 minus 2 times 2.263. Okay, and so your length, your height is 2.263. Your width is 7.474, and your length is 11.747, and your max volume, which was the most important, was 194 and some change. All right, that was a long video, I know, but you guys are doing awesome. And it's always good to relate what we're doing to real life application problems. Aloha. I will see you guys in class. We're going to continue to rock out these chapter 5 polynomials and polynomial functions. Good job. Alohas.